What's up, everybody? This is your boy Tech G back with another video to help you successfully pass the CompTIA A Plus 220 1101 certification exam. So let's get into it. In this video, you're going to learn about motherboard encryption techniques, CPU architectures, expansion cards, and cooling techniques. So let's talk about encryption. So security has become the major concern in the design, manufacturing, and use of computers. Hackers find vulnerabilities in software to get into computers and compromise the data. One method of mitigating the security threats is to have security processes separate from the software. And to do this, specialized chips have been developed to manage hardware security away from the CPU. Trusted platform modules and hardware security modules are designed for different tasks, but both are important to desktop and laptop security. All right, let's talk about the first one, trusted platform modules or TPMs. So trusted platform module, this is a chip embedded into the motherboard of a desktop or laptop that enhances hardware security. The task it performs includes generating and storing cryptographic keys to be used by the operating system and managing authentication of the user booting up the system. Because they are processed separately from the CPU, there is little chance that the CPU can be hacked to acquire the keys. The TPM provides full disk encryption capabilities and protects disks during the boot process until the operating system can complete authentication. The TPM chip actually has its own small operating system for generating encryption keys separately from the CPU. And TPMs, they are enabled in the BIOS UEFI settings and are designed to be sure that the operating system is authentic and that the correct owner is booting the computer, but they do not manage other security keys needed by applications. Every certified Windows 11 system comes with a TPM chip, and to view information about the TPM, you can open the Windows Defender security application, select device security from the left menu, and then select security process details to see more information about the TPM. All right, next let's talk about hardware security modules or HSMs. So a hardware security module, this is a physical device that provides extra security for sensitive data. This type of device is used to provision cryptographic keys for critical functions such as encryption, decryption, and authentication for the use of applications, identities, and databases. A hardware security module is not embedded into the motherboard. Instead, it is an added module or external device that can be added for storing security keys for general use. An important difference between TPMs and HSMs is that hardware security modules can store encryption data, but they do not generate the encryption keys as the trusted platform modules do. Because hardware security modules are not embedded into the motherboard, they must access the CPU via a USB mounted in an extension slot, or if being used over the network by way of TCP/IP. All right, next let's talk about CPU architecture. So the architecture of a CPU refers to how it is designed to process data with its instruction set architecture or ISA. The ISA tells the CPU what to do and how to accomplish it. CPU manufacturers, they have adopted similar architectures, and we're going to talk about them in this section real quick. First, let's talk about x64 and x86. So early CPUs from Intel were developed on the x86 architecture, which eventually allowed for 32-bit processing by the CPU. This means that 32 bits of data could be processed at one time, and the CPU could address up to 4 gigabytes of RAM. This worked well for the years until more complex software needed more memory and faster processing. AMD developed the x64 CPU, which greatly expanded the speed and memory access. And the two most common architectures in use today by CPU manufacturers are the x86 and the x64. Now, it is important to note that the x64 CPUs, they can easily run the 32-bit x86 architecture, but the reverse is not true. The Advanced RISC Machine or the ARM architecture. So RISC, that stands for Reduced Instruction Set Computers. This was designed to simplify CPUs from the x86 standard, making the instruction set smaller for tasks, enabled chip manufacturers to use fewer transistors, improving the efficiency of the computing process. ARM is the most widely used instruction set architecture. ARM processors are low cost, have minimal power consumption, encryption and generate lower heat, making them ideal for devices such as smartphones, tablets, laptops, and other embedded systems. However, ARM processors are also utilized in desktops and servers. Additionally, ARM architecture is implemented in operating systems such as Windows, Unix, Apple iOS, and Android. Let's talk about CPU cores, single core and multi-core. So a processing core, this is part of the CPU that gets instructions from software and performs the calculations for output. Early computers had single core processors to do all the work. As demands on CPUs grew, single core processors, they essentially couldn't keep up. So two or more physical processors in a system enable it to perform much faster when multitasking or running multi-threaded applications. However, as mentioned earlier, systems with multiple processors are expensive to produce and are best used in server and enterprise computing. Multi-core processors, which combine two or more processor cores into a single physical processor, provide virtually all the benefits of multiple physical processors, are lower in cost, and work with any operating system that supports traditional single-core processors. And the operating system essentially sees each core as a CPU. Let's talk about multi-threading. So CPUs process the data from the operating systems, and delays in moving data in and out of the CPU means that there was downtime. Designers found an elegant way to quote-unquote thread additional work into the CPU while it was waiting for other operating instructions. This way, one physical core could behave like two logical cores. This process, known as hyperthreading, allowed much more processing than with one core alone. As CPUs developed and added cores, multi-threading was designed as a method to allow multiple threads on each core. This works differently from hyperthreading. Multi-threading breaks each core into logically smaller CPUs to handle more sets of operating instructions, resulting in higher CPU performance. The relationship between the motherboard socket, the cores in the CPU, and the logical processing for multi-threading can be easily seen in the Task Manager in Windows on the Performance tab. Next, let's talk about virtualization support. So creating and managing a virtual version of a computer or any device is a rapidly growing sector in computing. Most current AMD and Intel processors feature virtualization support, also known as hardware-assisted virtualization. Virtualization support allows a physical CPU to be emulated as multiple individual CPUs that can be used in a virtualized operating system. This enables virtualized operating systems and applications to run faster and use fewer system resources. The benefits are too many to discuss here, but think of it as getting two or more computers running in software, but buying only one piece of hardware to run them. To check whether a Windows device has virtualization support enabled or disabled, you can navigate to the Task Manager and go to the Performance tab to view the details. In virtualization, this is essentially enabled and disabled through the BIOS UEFI firmware settings. All right, let's talk about expansion cards. So most new CPUs come with integrated video, which makes it sufficient for everyday use. However, users of graphic applications and gamers will likely find a benefit in upgrading to an onboard graphics card that has dedicated memory space for graphics. The more integrated graphic processors are called upon, the more memory is used for processing and the more heat is generated by the CPU. So let's talk about the first expansion card, which is called a sound card. So a sound card, this converts digital sound signals into analog sounds that are preferred by human ears. For most users, the onboard sound card that is integrated into the motherboard is fine, but some users want high fidelity sound for home theaters and music mixing. Purchasing an internal sound card that is more powerful and has more input-output options makes sense for professionals who work with sound. And another type of sound card is called an external USB audio sound card. So an external USB sound card, this can allow for higher quality sound and multiple adapter input-output jacks. These sound cards really look more like USB attached devices than cards, but they perform the same task as the cards. You can also add surround audio with USB-based audio devices, and this is a good solution for laptops and for systems with limited or no expansion slots. Next, we have a video card or a graphics card. So a graphics card, this is an expansion card which generates a feed of output images to a display device, such as a computer monitor. Graphics cards are sometimes called discrete or dedicated graphics cards to emphasize their distinction to integrated graphics. A graphics processing unit that performs the necessary computations is the main component of a graphics card, but the acronym GPU is sometimes also used to refer to the graphics card as a whole. And most graphics cards are not limited to simple display output. The GPU can be used for additional processing, which reduces the load from the CPU. And usually a graphics card comes in the form of a printed circuit board or an expansion board, which are to be inserted into an expansion slot. Others may have dedicated enclosures, and they are connected to a computer via a docking station or a cable. And these are known as external GPUs or eGPUs. Next type of expansion card is called a capture card. So video capture. This is the process of converting an analog video signal, such as that produced by a video camera, DVD player, or a television tuner, to a digital video and sending it to local storage or to external circuitry. The resulting data are then referred to as digital video streams, or more often simply a video stream. And depending on the application, a video stream may be recorded as computer files or sent to a video display or both. And a video capture card, this is equipped to receive HD TV, a higher quality signals via HDMI, DVI, or other similar components. And video capture cards, they have built-in hardware support for MPEG-4 recordings and can be used to capture video for training, game recording, YouTube, or broadcast purposes. And some video capture devices, they can connect by way of a USB port. Next type of expansion card is the network interface card, or the NIC. So a NIC, this is a computer expansion card for connecting to a network, such as a home network or the internet, using an Ethernet cable with an RJ45 connector. Almost every desktop and laptop computer manufacturer in the last decade or more includes a network interface card or built-in wired network port. Almost all laptops manufactured in the last decade also include a wireless network card that has antennas built into the frame of the display. In smartphones and tablets, they also include wireless networking and wired and wireless Ethernet network adapters. They can connect to other networks and to the internet. All right, next let's talk about cooling. So a CPU, this is one of the most expensive components in any computer, and keeping it cool is very important. The basic requirements for proper CPU cooling include the use of an appropriate active heat sink, which includes a fan, and the applications of an appropriate thermal material such as grease, paste, or a pre-applied thermal or phase change compound. In advanced systems, they sometimes require the use of a liquid cooling system instead. So let's talk about the first component, which are fans and heat sinks. So a traditional active heat sink, this includes a cooling fan that rests on top of the heat sink and pulls air past the heat sink in a vertical direction. However, many aftermarket heat sinks, they use other designs, and every processor requires a heat sink. A heat sink is a thin metal device that radiates heat away from the processor. In almost all cases, an active heat sink, which is a heat sink with a fan, is required for adequate cooling. However, if a system case or a chassis is specially designed to move air directly over the processor, then a fanless passive heat sink can be used instead. Aluminum has been the most common material used for heat sinks, but copper has better thermal transfer properties, so many designs therefore mix copper and aluminum components for their heat sinks. Let's talk about phase change materials and thermal paste. So before installing a heatsink bundled with a processor, you want to remove the protective cover over the pre-applied thermal material, which is also known as a phase change material on the heatsink. When the heatsink is installed on the processor, this material helps ensure good contact between the CPU and the heatsink to maximize heat transfer away from the CPU. And finally, let's talk about liquid-based cooling. So liquid-based cooling systems for processors, motherboard chipsets, and GPUs are available. Some are integrated into a custom case, whereas others can be retrofitted into an existing system that has openings for cooling fans. And a liquid cooling system involves attaching a liquid cooling unit instead of an active heat sink to the processor and other supported components. A pump moves the liquid, which might be water or a special solution, depending on the cooling system, through the computer to a heat exchanger, which uses a fan to cool the warm liquid before it is sent back to the processor. Liquid cooling systems are designed primarily for high-performance systems, especially overclocked systems. It's essential that only approved cooling liquids and hoses be used in these systems, so you want to check with the cooling system vendors for details, because unauthorized liquids or hoses, they could leak and corrode your system components. All right, so that was my video where we talked about motherboard encryption techniques, CPU architectures, expansion cards, and cooling techniques.